Here is my 4th Division B bridge of the season, where I did a bit of material optimization compared to the previous build. If you didn't see the last video, bridge number 3 weighed 9.24 grams and held 16.98 kilograms for a competition score of 2165. For this bridge, I managed to get the weight down to 7.52 grams, and it still held over 15 kilograms for a competition score 2659.6. I reduced the density of the 3/32 inch thick balsa primary beams in the legs, as well as changing to 1/20 inch thick balsa for the angled part of the leg beams. Both dimensions are still 10 millimeters wide. I also changed all the basswood components from 1/8 by 1/16 to 3/32 by 1/16. That includes the primary tension strips on the bottom, as well as the 3 horizontal cross supports on each side. I also changed to a simple X design using 1/20 inch thick balsa for the additional lateral support near the top. Here's the bridge being weighed right before testing, showing 7.52 grams. Again, this was after spending a couple days in the dry box at around 25% relative humidity. Here's the testing in progress. The initial 882 grams is the weight of the empty bucket, and I'll need to add 131 grams to the final displayed value to account for the dead mass of the block, S-hook, chain, and load cell. A quick note on loading speed. I found that in general, a fast loading process is best. Of course, that's much easier with an auto-loading system, but even with hand loading, try and minimize the amount of time your device has to hold the weight, especially when you get close to failure. The failure of this bridge wasn't terribly spectacular, and it's pretty easy to tell what happened even in real time and from the debris, but we can check out the high speed to see the details. Keep your eye on the back beam on the right side. You can clearly see the top part of the engineered beam fail first due to the inward bending forces. Here I'll show it again with the playback slowed down. I would say there's still plenty of opportunity for optimizing mass with this design, especially with the basswood components of the build. It will also be worthwhile to investigate different widths for the angled part of the beam. Thanks for watching, and I hope this helps you out with your builds this season.